All right, guys, this is chapter 11, capital budgeting. This is probably the most fun chapter and one of the most useful things in finance and financial management. So what we're doing today with capital budgeting is trying to figure out uh, what projects a company should take on or if they should take on these projects. So think back to really early on in the semester when we talked about the goal of financial management and what we're trying to do. Remember, we had three main goals. Um, One was, what is it that the firm does? The second, how do they pay for that? And then the third was the day-to-day. So that first question, what the firm does, what are they in the business of doing? That is capital budgeting. So, for example, Amazon, what is it that they do other than a little bit of everything? Um, they're a seller of goods. They connect sellers with buyers. They've got digital content. They are getting into having standalone stores. They have all these different sectors and different things they do. Each one of those decisions is a capital budgeting decision. Um, what you do is where you spend your money. So what do they invest in long term? What are these big projects they're taking on? Buying up shopping malls and new stores and uh, getting into brick and mortar stuff. All of these things are capital budgeting um, questions. So we'll talk about three different ways to determine should we take on this project, yes or no. So the three methods we're going to do today. First one is called payback period. And this one's very intuitive, but not very useful. At least not useful in the sense that we wouldn't use this alone to make a decision on. Um, it ignores some key things that we want to make sure we cover. The second one is internal rate of return, or IRR. And this one's pretty good. This one's used often and is a useful tool and good for decision making, but it's not the best. Hands down, the best method we'll talk about is net present value, or NPV. Okay, so we'll solve each of these. We'll talk about kind of the benefits, the advantages and disadvantages of all of these, and what the criteria is to make a decision. So simple example, let's say a restaurant in town is trying to decide, should they expand or not? Should they add on, let's say, outdoor patio and some new menu items and expand their business? Okay, so that's the question we're trying to figure out. Should they do this or not? So the most important part of this thing, obviously, we have to estimate what are the costs. So we need to know what's this going to cost us, right? How expensive is it to add on and to expand our menu and hire new chefs and whatever comes along with that. We need to know what are the benefits. Specifically, how are we going to make money on this later? Is it worth it? So will we have future cash flows because of this? And we'd like to know what's the risk involved in all of this. Okay, so with these capital budgeting decisions, a few key questions, like for the best techniques, we want to make sure we consider time value of money, right? We know $1 today is not equal to $1 tomorrow, so we want to build that into our analysis. We would also like to consider risk to some extent. if we could, it would be nice to rank projects, best to worst, and why. How do we rank them? Ultimately, our goal is to maximize market value for the firm. So is it going to do that? Can we measure the value added to the firm? And also, it should consider all cash flows. So if we have all of these things checked off, then we're in pretty good shape, and that would be a good tool for our analysis. All right, so let's go back to this restaurant expansion and put some numbers to it and try to calculate some of this. Let's assume the cost is $165,000. All right, so it's going to cost us $165,000 today to add on and do whatever equipment and hiring and everything else we need with that. And then we expect cash flows of $63,120, $70,800, and $91,080. All right, so these are future cash flows at a year, 2 years, and 3 years respectively. Okay, so our initial cost today, and then these future positive cash inflows over the next 3 years. All right, so first let's do this payback period. Very intuitive, it's just like the name. How long until we get paid back? So if we invest $165,000 today, cash outflow, we're paying that. How long until we recoup our money? How long would it take? So payback period, we're just trying to calculate time to recoup initial investment. And pretty self-explanatory. You'd have negative 165, add to it the 63,000, add to that the 70,000, just keep going until we break even. But we want to know exactly at what point do we break even. So let's try it. So our cash flows would be, currently we're at negative 165. All right, and then we'll add to that 63,120 in year one. So we're still in the negative, right? We would be at negative 101,880. Okay, and that's year one. So it's been 1 year. We've recouped 63,120 of our investment. All right, so now at year two, we're in the whole 101,880. We'll add to that next positive cash flow, 70,800. We're still in the negative 31,080. And that was year two. Remember, all of these are just, this is year one's cash flow, year two, and year three. That's where this timeline's coming from. All right. So we know after year two, at some point during the third year, we're going to break even. Like we've got 91,080 coming in, and we're only in the hole negative 31,000. So roughly a third of the year. But if we want to know exactly how long into that year it would be, once you see that this is about to flip from negative to positive, then we just divide. So we have 31,080 left to pay off. During that year, we're going to make 91,080. So just divide to get your actual percentage. And I got 0.34. Okay. So our payback period is 2.34 years. And that's it. That's how you solve payback period. Now, to use this as a decision-making criteria, it's very arbitrary. It would just be something like, hey, here's the project. We want to be paid back in less than 2 years, 2 years or less. So if that was the decision, then you would say, all right, well, we're going to reject this project because we're not paid back in 2 years. And it's not a very good criteria. Look at our considerations. Is time value of money considered? No. Is risk really considered at all? Not really. We don't know how these cash flows were estimated, but there's no other cost involved that are considering risk. I'll explain that more later. We could rank projects, I guess, based on how quickly they're paid back. So we could do that one. Value added to the firm, sort of, not really, and considers all cash flows. No, it considered part of this one, but not the rest. Like, what if after this year, the next cash flow, just for example, what if it was like 568,000? So huge, it's gone up 5 times. Well, we completely ignored that cash flow. We're just concerned with how long until we get paid back. So this is good information to know. We would like to know the payback period, but more as like a supplemental info to the firm and the project, not necessarily this is how we're going to make the decision of accept or reject. But again, if you did make the decision that way, it's completely arbitrary based on whatever I tell you. We want the payback period under 4 years. Would you accept or reject? Well, sure. Based on that, then we would accept this one. Okay, so moving on to a better method. Let's solve for internal rate of return now. Okay, so we're going to use the same cash flows. And when we solve for internal rate of return, we're basically figuring out what rate are we making on these cash flows. The method to do this using your calculator, the class calculator, you're going to enter in all the cash flows, and it's very similar for this one and net present value. So if you can get these two down, you're in good shape. All right, so internal rate of return, when we're solving these, on your calculator, you should see a CF key. It's right next to the second button. So if you hit CF, it pops up, it says CF0. So you type in your first cash flow, 165,000, and make sure you make that one negative because that's the initial cost. After you hit that, hit enter and hit the down arrow, and then it should say C01. So then just enter your second cash flow, 63,120, hit enter, down arrow. Now it should pop up and say F01. That's asking for the frequency, like how many times this cash flow of that amount happens. So it only happens once here, so you hit the down arrow again. Then it says C02, just continue, 70,800. Enter, down arrow, F02 is asking for the frequency of that second cash flow. Hit the down arrow again. C03, repeat, 91,080. Enter, down arrow again. Then it should say C04, and now you're finished. You have all your cash flows in there. All right, once you get to this point, if we're solving for IRR, just hit the IRR button. It's second row from the top towards the right. So you hit IRR and then hit compute. And it should spit out an answer, 16.1322. And this is a percentage. So this is telling us what rate we're actually getting on this investment. We spend 165 today, we get these cash flows at different time periods. That's the rate we're actually getting. All right. Now to solve for NPV, hit NPV on your calculator. it's going to ask you what I is. I equals, and it's just 0, which I haven't given you this information yet. But if we had, so we would have some sort of required return or a discount rate that's given. Okay. What we just solved for previously in the last section was our WACC, weighted average cost of capital. Usually that's what you use as your discount rate. That's the cost for the firm to make money. So we would hope, the cost of the firm to get their capital. So that's the appropriate discount rate to use when considering these projects. So for this one, let's say it's 14%. So you enter 14 for I, hit enter, NPV, or down arrow, sorry, and it'll ask for NPV, hit compute. So NPV, 6,323.12, or 0.13 if you round. And that's in a dollar amount. Okay, so IRR we solve for, it's a percentage. NPV we solve for, it's in dollars. So this is the actual dollar value added to the firm. Okay. So our criteria for this one, for the accept or reject for NPV, is if it's positive, if it's greater than 0, we accept. You'd accept the project. If it's negative, you'd reject. So does this mean we're only getting $6,300 in return after all of these cash flows? No, because remember our discount rate here, our required return, was 14%. So this means we're discounting each of these cash flows back to today at a 14% rate. After we do that for each one, subtract your initial cost, and this is what's left over. Okay, so in other words, net present value takes all future cash flows, discounts them back to today. So you have a sum, a present value sum, and then you still have your initial cost as of today. So subtract that from your sum of the other positive present values. Take the difference, whatever's left. If it's positive, you accept. If it's negative, you reject. So that's what the calculator's doing. You enter in each of these cash flows. You tell it what time each of these happens, year 1, year 2, year 3, and the rate you want them discounted back. And that's what it's spitting out. That's what it solves. So IRR, what is it doing? Well, it's figuring out what rate makes the NPV equal to 0. So that's the rate you're actually getting that forces NPV equal to 0. So if you think through that for a second, if you discount each of these back at a certain rate so that the initial cost offsets those completely and it's 0, what rate does that? What rate forces NPV to 0? So the criteria for this, if IRR is greater than required return, then we would accept. Okay. So both of these usually will agree with each other, IRR and NPV, but we listed these and I kind of told you early on, NPV is actually the best. So let's talk a little about what's the difference, like why is this one any better? It seems like they're very similar. They both have time value of money. They both have risk involved. Risk would be that our weighted average cost of capital, the way we solve that to figure out our required return. We've got beta in there and we've got all these risk measurements, figuring out that requirement. Value added to the firm, yes, both tell you that, just in different methods. One's in a percentage, one's in a dollar amount, and they consider all cash flows. So this is where they differ. The ability to rank projects, we need NPV to do that one. So if we have what's called mutually exclusive projects, mutually exclusive projects, like we've only got one project that we're able to do. Let's say we own some land in town and we're going to build something there. We could either build a restaurant or an apartment complex. We've got to do one or the other. We don't have the space or the cash or whatever to do both things. So we'd estimate the cost of each and estimate our cash flows, and we could figure out which one we would do. So with mutually exclusive projects, when we're going to rank projects, use NPV. All right. And then it's pretty simple. Whichever one has the greater NPV is the project that wins, if you have to pick just one. Now, if they both were positive and you could do both projects that weren't mutually exclusive, then you'd accept both. But again, if it was just one, pick the one that's the higher net present value. That's the dollar amount added to the firm, taking into account this cost of capital or our required return as well. Okay. One other thing with NPV and IRR. If we have unusual cash flows, meaning so far it's just been negative and then positive, 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 and it stayed that way. Well, an unusual cash flow would be something like negative, positive, then maybe it goes back. We have another cash outflow, and then it's positive again, and maybe it switches multiple times. If it switches more than once at all, so even just this first part, negative, positive, positive, then negative again, that's unusual, okay, for our terms. So it can only have one sign change from negative to positive. If it goes back and forth 2 or more times, then it's unusual cash flows. If that's the case, you need to use NPV and not IRR. It's IRR ends up, you have multiple times that it forces NPV to equal 0, and we won't get into the math behind it. Just trust me. Okay, so if the cash flows are unusual, use NPV, not IRR. Otherwise, both usually will give you the same answers. Mutually exclusive, NPV. Again, not IRR on that one. Payback period, good to know, not good to value projects or rank them or use that as our decision-making criteria. Okay, so that is capital budgeting in a nutshell. I'll post these problems on Moodle and take your time, work through these. You should have everything you need to solve these now. If you have questions, let me know, and good luck on this stuff. We will have our next test on just the last 3 chapters. All right.